Lesson 12.5, Common and Natural Logarithms. This is an easy section because a common log is a log that has base 10. Log base 10 of x, sometimes we just write it log of x. If it's written just log of x, that means the base is 10. And the cool part about this is that your calculator will calculate log of base 10. So when I say I want to know what is the log of 23, and I want you just to estimate it, all I mean is stick it into your calculator. How easy is that? So on your iPhone calculators, when you turn them sideways, they won't be right side up, but if you turn it sideways, just to the left of the numbers, you'll see a log. Some of them will say log 10, log base 10 on it, and some will just say log. So you'll just press in 23 and then press that log base 10 number, and it should give you 1.3617. So do it now and make sure that you know which one it is and how to work it. Same thing if you have a decimal, it's the same thing. You're just going to press the 0.00236 and then the log button, and then you should get negative 2.6271, and it'll go on and on and on and on, but just cut it off there. All right. Now, if you do happen to have a scientific calculator, you're actually going to press the log button first. So you'll press log and then the number and then enter. But I think most of you are using your iPhones. All right. So now we've got to do something with those. You know, I'm not going to just let you off easy. So this information is handy specifically for finding sound intensity levels. Sound intensity is measured in decibels, and we use this formula. The decibels equals 10 times the log, and this is log base 10 because there isn't a base listed. So log of intensity over the initial intensity. So this I base 0 that indicates the faintest sound that the human ear can hear, and scientists have studied this, not I, but scientists have found that 10 to the negative 12 power watts per meter squared is the faintest sound that the human ear can hear. So that's what we're going to use for the initial intensity. All right. And so what I have here is I've got a problem that says a motorcycle has sound intensity of about 10 to the negative 2.5 power. I want to know what is the decibel reading. So we put that in decibels just because it's uniform and it's easier to compare. So what we're going to do is we're going to use the formula. Decibels equals 10 times the log of intensity divided by the initial intensity. We're going to fill in what we know, and we're going to solve for the decibels of this motorcycle. So 10 stays 10, and then we've got log of the intensity. Now the intensity of the motorcycle we found was 10 to the negative 2.5 power, and that's over the initial intensity, which we know is 10 to the negative 12 power. Now we've got all these tens, which should make life easier for us, and guess what it does? So because of this, we've got negative exponents here. What we can do is we can move this negative 12 up to the numerator, and remember when we flip a negative exponent, it actually becomes positive. So what we're going to do is in this fraction, we're going to simplify it by saying we're going to say 10 to the 12 minus 2.5 power, and then we're just going to have that over 1, because if we have, let's move it over here. So 10 to the log of 10 to the 12 minus 2.5 is what we're doing. All right, so we flipped the negative 12 power and we flipped it up into the numerator. We're going to keep this negative 2.5. We could have flipped it down, but we want to combine it anyway. And because it's smaller than this 12, it's going to reduce down. So now we're going to end up with 10 log of 10 to the 9.5 power. All right, because 12 minus 2.5 is 9.5. Now check this out. Log base 10, because we don't see a base, it is 10, right? So log base 10 of 10. Remember that if we have a base of the log and the log that's exactly the same, then our answer is just the exponent. Remember that? So remember log base 10 of 10 to some power is the same as just that power. So this is just 9.5. So now we simply have this 10, we didn't lose it, times 9.5, which is just 95 decibels. All right, so that's where this comes in handy. I think we did it just in the last section. If you've got a number, a log with the same base, then remember that is equal to just its exponent, and you're done. All right, so that would be 95 decibels. Easy sneezy. Now, the next thing we have is natural log. Now, natural log, this is just as easy, but it's a little harder to wrap your brain around because E is actually a number. Kind of like pi is a number. It's exactly the same thing. E stands for an actual number, but it's a number that goes on and on and on and on forever. It's a decimal that never ends that, once again, mathematicians smarter than I have come up with. And so base E is the natural log base. All right, and so just trust me, E is a number. Okay, so when we have log base E of a number, what we do instead of putting that E there, we simply say natural log of X, so ln of X. And so when you see ln of X, that does mean it's a log, but it means that it's a log base E, which is this number that is, I think it's 2.7 something, 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 and goes on forever. All right, so once again, this is super easy because you can put it into your calculator. If you look in your calculator, on mine it was just to the left of the log base 10 is the ln, which is the natural log. So all you do is put in 83, natural log button, and you should get 4.4188. If you don't, you need to check it out and see what you're doing wrong. All right, once again, if you have a scientific calculator, you'll press ln first and then 83. On your iPhone calculator, 0.0055, press the ln key. You should get negative 5.2030. Did you get it? All right. And again, I can't make it that easy. Let's do something with these numbers. When we're dealing with money, I love money, don't you? All right. When we're dealing with money, and we've done compound interest before, we can, if interest is compounded continuously, there's a formula that will let us know exactly how much money we're making. All right. So this formula tells us the time that it's taken for P number of dollars, that's your principal, the amount you start out with, to grow to A dollars. That's the amount at the end of this T amount of time. And R, of course, is the rate of interest. So if I deposit $5,000 and it earns 5% annually, compounded continuously, I want to know how many years is it going to take to double? How many years is it going to take to get to $10,000? Well, simply start out with your formula and put in what you know. So we've got 1 over the rate. So 1 over our rate is 5%, so 0.05. Times the natural log of the amount that I want it to reach is 10,000, divided by the principal that I put in, which is 5,000, and that's going to give me the amount of time that it takes. So now all I have to do, I've got a formula that simply needs to be reduced. So this 10,000 over 5,000, 10 over 5 is 2. So this is going to be the natural log of 2. And 1 over 0.05, if you take 1 divided by 0.05, that's just equal to 20. So now you simply put it into your calculator. Log of 2, or natural log of 2 times 20, and you should end up with about 13.86 years. Easy sneezy. All right, that's all I got for today. An easy lesson, quick and simple, and I'll see you next time.